Hello and welcome to the show. My name is Bret. Thank you so much for being here. If you're watching this live, congratulations. You're here and you get to ask questions of my guests and be a part of the conversation. If you're watching this after the fact, I'm sorry, come back on Thursdays. I'm here live every Thursday for 4+ years now. In fact, we're coming up on our 200th episode. We'll talk about that at the end of the show. I'm excited to talk about what we're going to do for the 200th, but this is 198. So 198 weeks of talking about containers, and we're just getting started. Sorry, I have a little bit of cold, so I'll be nursing that throughout the show. Apologies. I think everyone right now has got something coming out of the holidays. So thanks for being here. I know you're getting busy back in your work week as the new year begins. And this is an exciting topic today, so we're going to get to it real quick. But first, I have a few announcements. As of course, you probably heard, if you've been here before, we have the DevOps server over here. You can look at that on my screen. This is 12,000, almost 13,000 people in here talking about DevOps every day. It's now to the point where it's too much for me to keep up with. So we've got some great other people in the community volunteering to be moderators. You can also get involved as well. Please come join us. That's at Devops.fan right above me. Discord is a great community place for chat. It's basically the better version of Slack for open communities, and that's where we hang out all day. And something else you may have heard, I've been mentioning it a little bit quietly for the last few months, but we are starting to gather email addresses for people that are interested in my next course. My next course is going to be live. So this is going to be totally different than the ones you've seen on Udemy. This one is going to be taught live over the course of a few weeks, and it's going to be very specific. It's going to be tactical, and it's going to be about an hour and a half a day, every couple of days. You're going to be with other people in a Zoom, learning and doing, more importantly, doing the things we're going to be learning, and we're specifically going to be learning GitHub Actions for one of the topics we're talking about today, building your Docker images, doing a lot of your automation in GitHub Actions, and then deploying to Kubernetes using Argo CD. So we're going to take two different tools, combine them together, and hopefully you'll be able to implement it in your own projects during the course. So signups are happening now. Basically, we're getting everybody on a waiting list because we haven't announced dates yet, but those are expected to be this quarter of 2023. So you can sign up there. If you sign up and get on the waiting list early, you will get I think something like a 25% discount. I should know that, but something around a 25% discount on the price. And of course, you will get all the content, all the videos, but this is a live scenario. So you're getting basically consulting at a fraction of the price of my traditional consulting. And I hope you like it and sign up. So I'm going to give you the link into chat for that. And that is it for announcements. Of course, there's merch and other things, course coupons, all that stuff below. Just look at the description for everything else going on there. But let's get to it. I've got on the show today two special people from, we're actually all spread out all over the globe. It's kind of fun today to have this kind of situation. So in the middle there, we've got Kyle Galbraith. Sorry if I messed that up. Kyle Galbraith. I mistakenly did not learn how to pronounce the names correctly before the show started. Thank you so much, Kyle, for being here. And then Jacob Gillespie on the end there. Thank you both for being here. Yeah. So
thank you.
We're all, several of us are all nursing our cold, so we're going to apologize now for any, I've got cough drop in my mouth. Like, it's real life here, folks. We're doing it anyway for you. I was thinking about postponing, but hey, let's just do it. So we're here today to talk about something that I have been mentioning to my friends and kind of keeping a little bit of a secret, is this thing called Depot that you all came up with. So some of us have had this problem, didn't know there was a fix for it. So real quick, how did you come up, where would the idea for this product come out? It's probably come out of pain, I assume. Where did that arise?
Yeah, the idea for Depot definitely came out of living with the pain of slow Docker image builds inside of CI providers like GitHub Actions. So Jacob and I have worked together for almost 5 years now at two different companies, largely running platform teams, DevOps, infrastructure teams, that type of jazz. And part of our roles throughout those years was optimizing CI/CD pipelines, optimizing Docker files, making Docker image builds fast, and just constantly being frustrated with the limitations imposed by CI providers, things like lack of persistent disks for caching, so having to save and load cache over the network, lack of multiple architecture support, which became really relevant over the past 2 years or so with M1 MacBooks needing to build images for ARM CPUs, but also just like limitations inside of CI providers in terms of CPUs and memory. And so Depot is born from living with that pain for so long, and it's our attempt to start chipping away at that problem and providing a better build experience for Docker images.
So was this like a conversation, Jacob, where the two of you were sitting around going, we should do a startup and fix this problem? Like, how exactly did that happen?
Yeah, Kyle and I were working on various like side projects together, and thinking just generally about like builds, package builds of all sorts. Um, yeah, and I think we had a conversation on one point where we were like, you know what, Docker is like the most painful one. Like it is, everybody is doing it, but like it can be very, very slow and it can be very hard, or potentially like impossible with some of the limitations of CI providers to make it fast. Um, at the time in our day job, we had some Docker builds that were taking like north of 30 minutes, and just like trying to wrangle those. So yeah, um, very much of a, yeah, this is a thing that we wish we didn't have to experience. So
Yeah. And I think a lot of us, I mean, when we're all new to Docker, and we kind of talked a little bit about this before the show, is when we're all new to containers, there's a lot of shiny, and we're all enamored by, oh, I can just run a single command regardless of the machine I'm on or regardless of the environment, and it's going to make my container look and have the same dependencies and the same requirements. And that part's kind of magical. But as we all mature and we want more out of it, we tend to all hit this. I don't even know if I have a name for it. I don't know if you all have a name for it, but this problem where the multi-platform problem of how, now that we're all dealing with Mac M1s and the looming ARM race on the Windows side of things, which I'm very excited to watch happen. I think a lot of my friends are getting the Microsoft Dev kits, which are all ARM-based Microsoft Windows machines, kind of like a Mac Mini M1 kind of thing. And I see that all happening, but a lot of developers, we have slow builds. Obviously, that's a problem I think that a lot of teams struggle with, especially with old monolith applications that were not yet, not everybody's in Go and Rust microservices yet, right? So we have a lot of this old stuff, and I work with a lot of teams on that. And then we have this multi-platform problem that people still don't quite have a grasp on. In fact, Docker almost, especially Docker Desktop, it kind of makes it a little magical where it just runs it anyway, even though you're not on the same architecture and it's less efficient, but there's an inefficiency there. So how do you describe that pain to people that like if you're an elevator pitching someone on, oh, you may not realize you have all these problems. How do you describe it in a better way than I just did?
The way I usually describe it is Docker is really easy to get started with, but it's riddled with hidden complexities that can
Yeah.
be challenging, whether we're talking about multi-platform builds, whether we're talking about Docker layer caching. That's something that's often, in our experience as platform engineers in the past, often having to educate developers on something like Docker layer caching because it's not immediately clear, right?
Right.
Folks often see I can do Docker build and package up my dependencies with its application, and I can deploy it to Kubernetes or ECS, or I can run it locally with Docker Compose. But there's a lot of hidden complexity inside of a Docker file just by itself that if you don't understand some of the inner workings of what Docker is doing or what decisions are being made as an image is being built, you can really end up in painful situations. Whether that's I watched the episode that you did with the Chain Guard folks. Whether that's you end up with dependencies that have CVEs up the wazoo, and you're putting that into production, or you end up with a Docker image that's 10 gigs
Yeah.
and could actually be 2 gigs, or your build time could be 90 seconds and it's 20 minutes because you're not actually making use of any Docker layer caching, because the second run statement in your Docker file busts the cache every single time you build it because it's doing something dynamic. So,
right. Yeah, in fact, just what you mentioned there, I realize there's a whole lot of assumed knowledge even to understand a lot of these problems sometimes. And it's almost like battle wounds of you take on Docker as a project, you do it first on your machine, everything's wonderful. Docker Desktop is a fantastic product. It hides a lot of the complexity of what Docker's doing in the background. And that's kind of the thing, right? We all didn't manually build our own Docker with 20 different isolated tools to realize what's going on in the background with the caching, on the build caching and stuff like that. And you do it in CI. Of course, a lot of CIs, not all of them, and we're actually going to talk about that, but not all of them solve some of these problems like caching today. But some of them have tried to just make that a default feature. But a lot of us, we got started with Docker back when we were using our own Jenkins, and we maybe had build farms, right? But those build farms weren't using shared caching in any way, really, especially for Docker, because that was a new thing. And so we all had to kind of learn over the years of, oh, this is what I have to do on my servers, which is different than on my local machine. And I have this very special process or this workaround that I have to use. And new people that are going through my courses, hello to you out there, if you're new to the world of Docker and Kubernetes, they may not realize these are looming problems on the horizon for them. So, okay, we've mentioned already, I've mentioned multi-platform. You talked about slow builds or large image sizes that when they didn't need to be. And then we have the caching problem. Maybe is that a good one to start with? Maybe just talk about what does Docker do by default and how is that different in CI when it comes to caching?
Yeah, I think that makes sense. Yeah, Docker layer caching comes into play when you're building an image in a Docker file. And the algorithm Docker uses is relatively straightforward. Like in a Docker file, you're going to have multiple steps, starting with a base image. And then you're going to alternate either like copying in files from somewhere or running run steps. And Docker, when it's building the image, will kind of go down that list. And if it's done the thing before, it can reuse that same layer again, which is pretty fast. But as soon as you copy a file in or something that is different, then from that line onward, Docker will rerun all of the following statements in the Docker file. So on your local machine, that often functions as you would expect. If you have written your Docker file to take advantage of that, it's another challenge. It's optimizing the Docker files to take more advantage of that layer cache. In CI, that could be a problem because your CI environment doesn't have any of the cache from before. So by default, it will rerun everything, which can be really slow. And then you get into some of the workarounds of like saving and loading the cache off to somewhere else in between builds so that you don't have to do as much. But that in and of itself takes time as well. So that can like eat into the time that you might be gaining using that cache.
Yeah, in fact, I would probably just blanket that statement by saying if you're a team of 2 or less, you can maybe get away in a world where you have one build machine and it's the only build machine, and then the caching is okay. But the minute you have more than one caching machine, you now have to worry about, I guess we're going to label as distributed caching, I guess is really what we're calling this problem in CI. And I can remember a time when we didn't really have, especially for on-prem, we didn't really have solid solutions for how to get Docker caches moved around or copied or whatever. And so I remember that we had Jenkins farms where we would isolate the Docker builds to only a couple of machines, and we had to let everybody know that your builds may or may not be slow, depending on which machine they land on. And when we decide to replace those machines in 3 or 6 months or whatever, they will be cold. It'll be like a cold start, and they'll be slow again until the caching gets manually built on each machine enough. And it was because we just had to fake it. We just didn't really have any tool. And of course, things are a little better now, especially with tools like this. But it's still an issue where I feel like every time I work with a team, I need to go and check when we're first creating Docker build pipelines or workflows. I always want to go check and see that cached word, right? Like looking in the build kit logs and looking for cache. And that tells me, okay, I'm not doing it wrong. Like I'm utilizing something in the background that's caching my layers. And more importantly, maybe my Docker file is designed correctly so that I'm not busting my cache. I think it's maybe a term we need to define for people. When it comes to Docker files themselves, what is cache busting? What is it a bad thing when you're busting the cache? Can you describe that a little bit to the audience?
Yeah, so cache busting would be you have a 10-line Docker file, and the second line is a run statement that's doing npm install or something like that. And in that scenario, if you're copying in the entire source code of your repository before that, of course, the entire source code of your repository is going to change. And so your first build is going to copy in your entire repository, it's going to do npm install, and then the rest of the steps, and then that cache is going to exist on disk, or if you're using something like GitHub Actions, you export the cache off to somewhere else. But then when you go to run the build again, it will get to that second step, and because you've copied in your entire source code repository, that invalidates the cache at that point. So the cache is now busted, and so all run statements must rerun from that point forward. And this is because, like Jacob said, Docker's layer caching is quite simple. It's just walking down the Docker file. So if one layer changes, all subsequent layers that come after that must be rerun. So effectively what we're saying is a Docker file does not have a dependency graph. So each line inside of a Docker file doesn't know about the other lines. And so you can end up in really nasty scenarios where you're busting your cache on the second line of your 20-line Docker file every single build. And so your build could be 30 seconds, but it's 10 plus minutes because you're having to redo the whole thing every single time.
Yeah, and it's 10 plus minutes every single time. And that's really what I think wears teams down. And so that's why, for those of you watching, if you're relatively new, if you're still taking the courses and stuff like that, that's why you'll see in all the Dockerfile examples, the good ones, we always install your dependencies first, which is why you will often see two copy lines where you have the copy in my package JSON or my requirements text or whatever. Then you copy and source later, because that's what we're trying to do, is prevent that cache busting from happening too soon. So that because a lot of times, other than testing or maybe, I'm trying to think, front-end websites where you may be building CSS files or whatever, usually I find it's the requirements, it's the dependencies that take a lot of the time, especially in my world of Node.js. Like that's where all the action's at, is installing those ridiculous amount of requirements and dependencies in the package JSON. And so we always want that to be a cache as much as possible. So that's just one reason to maybe try to be deliberate about your CI environment. So maybe we can talk a little bit about how you came up with this idea for Depot. Great name. Oh, was I just muted?
Yeah, I think you're muted.
Okay.
Wasn't sure.
If it was you or me. All right.
Yeah.
I guess that the ask there, I'll repeat everything I just said earlier, but later. I was trying to mute my cough. My apologies. What is Depot trying to solve in this world of CI builds, like local builds? It sounds like it's trying to do a little bit of both. So could you explain maybe some of the problems you're fixing with Depot?
Yeah. So Depot is offloading the Docker build to a remote build machine, and we kind of have specialized Docker build machines to do that task. That does help in several different cases. CI is a big one. So in a CI environment, we mentioned the problem of like having an ephemeral environment, so like your cache isn't there, or you would need to like set up your own persistent build machine and route builds to that. Depot kind of provides that excuse me, persistent build machine experience of when you rebuild a project, it is going to get the same disk cache as when you built it last. So that makes the remote build or the CI build environment behave similar to like the Docker desktop experience. The other thing is there could be reasons why the environment you're trying to build something in doesn't have the right resources. So that can either be like too few CPUs or too little memory, which might be a CI concern if you're using like a public CI provider. Or it could be something like CPU architectures. So maybe you have an Intel laptop, but you need to build an ARM image or vice versa. Or you have a machine that you don't want to install Docker on at all. Yeah, so like routing those builds to a remote machine that is running the native platform that you'd like to build with the resources that you need. Yeah, that is kind of what Depot is doing today.
Yeah, I like that. I like that you can run it locally. So this isn't specifically. I mean, this is clearly something that can be taken advantage of in CI, but it's not just CI, because I find out one of the freedoms that Docker gives us is that we can, it's the whole solving the works on my machine problem of I can run this from any machine. I can run the build command from any machine. And that's, of course, gotten a little more complicated with multi-platform now. Docker does a pretty good job of trying to solve that locally with QEMU, which we're going to get into because that's an area that I'm passionate about. But I like that I can just basically, it looks like I can just replace the Docker CLI on my machine with the Depot command, and the same build command will do it, but it looks locally, but it's actually happening remotely. Is that how it works?
Yep, exactly. So we have our own Depot CLI, which is a drop-in replacement for Docker build effectively. And so it takes all of the same parameters that Docker build takes today, with 2 additional parameters for like how you route a build to a Depot builder. But outside of that, you can use it exactly as you do today. And that's something that was really important to us when we built Depot from our own background and experiences as platform engineers, asking an entire engineering team to wholesale replace their CI system or wholesale replace their build process for some new tool is a monumental ask. And so with Depot, we really aim to meet developers where they already are. And so it was really important to us to provide that same experience that Docker build gives today. And you just swap out Docker for Depot and you get faster builds with the persistent caching across builds automatically. Users that are in the same Depot project can use each other's cache. So this is a perk of Depot, of the fact that we're providing that static build machine experience, but at the disk level. So the disk can be shared across builds, across developers. So this is really handy if you're a team of 10 engineers and you're all building the same image locally. If I built the image 2 minutes before Jacob and he turns around and hasn't really changed much, he just needs to build the image to run it locally as well, he gets to use the same cache that I just built.
That's actually pretty slick. I really like that. In fact, someone who's obviously a big Docker fan, I keep thinking to myself, man, Docker should have done this. This is a great idea, because for someone who's a consultant that helps other teams often optimize their build paths, their pipelines, workflows, whatever you want to call it. The building and testing parts tend to take up 90% of the time, right? Like it's usually that's a lot of the effort. And now that we're all getting into multiple deployments a day, that means that our CIs are usually building dozens of times a day, if not more. And this problem just magnifies itself very quickly. Like you get people hooked on Docker and they're like, oh, great. And then you build it for them in the CI and they're like, okay, that wasn't that hard. And then suddenly there's a moment where they all just realize, our 10-minute builds per person, per CI run are just no longer viable. Like that is the thing
Mm-hmm.
in our entire workflow that is preventing us from deploying more times a day or whatever. And it doesn't 10 minutes doesn't sound like a lot, but when you're talking about doing it 25, 30 times a day, it suddenly is the entire day. And I can attest that there are very few times where I've been able to do a drop-in replacement of one tool for another, and I suddenly get a bunch of time back. Like on a rare occasion, you can maybe ramp up your CI workers and maybe like get a bigger machine and maybe make it a little faster. But that even in itself is often not the real solution, because often this stuff isn't designed to run parallel, so it doesn't really use more CPU when it can. So all right, let's say I'm in a scenario where I have a project. You mentioned the project, by the way. So when you say project, you mean like, is it a Git repo? Is that a project?
Yeah, a project
Yeah,
could be a
so
Git repo, could be a Docker file. It's really we try not to put any constraints around it. So there's some folks that for each Docker file they have a project. There's other folks that they have 10 Docker files going to one project. So it's really about how somebody wants to leverage the cache. So if you're using 10 Docker files to one project, you're obviously going to fill out the cache at a faster rate if you're building all 10 of those different images. But it still works. So you can totally do that. You won't ever run out of disk space. You'll just expire cache at a quicker rate.
Oh, okay, interesting. So yeah, whether I'm in a mono repo or I don't know, macro repo. I don't even know what the opposite of mono repo is. A one Docker file per repo approach, which I've done both, and people often on this channel actually ask us which is the right approach, and I always say both. It's kind of like monoliths or microservices, both. I think a lot of us are doing both, and a lot of teams end up having both. So I would set this up on a project on a Git repo that already has a Docker file, and then I would download the Depot command line locally, and then I would gain the benefit locally. But if I add it into my CI and replace whatever the Docker build command I'm using in CI is with this, it sounds like the caching that the CI builds for me is now available to me locally, right? And available to every one of the team members that work on that same project. So we're all, us and the CI, the robots, are all sharing the cache. And let's talk about this multi-platform bit for a second, because I'm not even sure everyone watching understands what that really is. I'll just start off by saying that I'm on an M1. I have multiple Intel machines in my little hobby closet in the corner, but I'm operating on an ARM all day long. So quite often, I myself need, when I build an image, I need to build it multi-platform, and that's not automatic. So could you talk a little bit more about like how Docker normally does it and how you do it?
Yeah, so excuse me, Docker will build by default for the platform that you're on. So if you run Docker build today and you're on an M1 Mac, it will attempt to build an ARM image, since the M1 is an ARM-based chip. And if you're on an Intel device, it will attempt to build an Intel image. You can ask Docker to do the opposite. You can ask it to build for different architecture by passing in a command line flag. If you do that on your machine or in like a CI provider like GitHub Actions, and you're specifying the platform that isn't native, so like in GitHub Actions, if you're building for ARM, it will use an emulator to do that. So QEMU is the one that they integrate with. Basically, that piece of software simulates the alternate chip. And then that will build an image where all of the like native stuff compiled inside that image is built for that CPU architecture. Docker also supports something called a multi-platform image, which is effectively just two or more images sharing the same tag built for different architectures. The cool part about that is then when you go to Docker run it, it will just download the one that's native if available for your platform. So I can have an app that I build on my M1 Mac and run there, and maybe I deploy it to a cloud provider that's using Intel machines, and each one will just download the correct, the correct image for that platform. The emulation can be really slow, like a whole order of magnitude or more slower, since it's having to like simulate a whole CPU inside of a CPU. So the faster way to do it, and the way that Depot does it, is you can actually connect to multiple builders to Docker. And you can say, like, this machine is responsible for Intel, this machine is responsible for ARM. And Docker is smart enough to route the builds to the correct machine and then combine the result. So with Depot, if you ask for whichever platform you ask to build, or if you're asking for multiple platforms, Depot will start cloud VMs that are native. So we'll start an Intel VM for Intel builds and an ARM one for ARM ones. And you don't have any of that emulation. So it doesn't use QEMU at all. So often we can see like builds that should take 5 minutes that are taking an hour or more because they have to be emulated, drop back down to that like less than 5 minute build time.
Right. That's a great explanation of something that it's almost like a hidden complexity, because the fact that Docker, it automatically builds for the platform you're on, which is fine when you're on local machine. That's kind of what you want. And so when you're developing locally, it just kind of figures it out. And excuse me. For those that are watching, if you didn't know, if you go into Docker Hub and let's look at the Nginx image, you can actually see all these different architectures with the same tag in the same repo. And that's technically separate images, all in the same repo, built on different architectures. But your machine, and back basically in the background, Docker is silently saying, hey, I'm trying to pull an image and I'm on this architecture. Do you have one for this architecture? And then the registry will say yeah or no, based on whether it has one or not. And teams are having to get involved with this more and more, because we're now, running ARM on our local machine and deploying to servers that are on Intel. Or now, if someone who's followed AWS's Graviton series, which are fantastic, by the way, cheaper, faster, way better networking, but they're all on ARM. You're now deploying, if you want to save money on AWS, a lot of people are looking to save money. They go to Graviton, which is ARM, but their images were usually designed for Intel or built for Intel. So this is one of those things where I feel like teams don't know about it until they get more mature in their evolution of infrastructure and their team, and then they realize, oh, we have to build for multi-platform. We were talking before the show. I just have a simple Jenkins image that I'm building on GitHub that, using QEMU, the emulator that is a Linux emulator for other platforms. Docker is nice and bundles it in, like you said. It takes 9 minutes to build a very simple, I think it's a Ruby app, and it shouldn't take 9 minutes, but that's the QEMU performance penalty, essentially, for building a 32-bit ARM image on an Intel 64. So you're saying that you guys, you basically have the servers that are the architecture that you need to build on, so there's no necessary emulation involved, thus the performance penalty. This leads us into the question, actually. Thank you, Ryan. You mentioned training with regards to Dockerfile best practices. The example local build takes 20 minutes on Depot. It takes 5 seconds. Is that optimizing the Dockerfile, better CPU or memory, or is it Depot magic? Or all three?
It's usually all three. Depot magic sauce with the caching and multi-platform support is a chunk of that. The other chunk of it is definitely optimizing Docker files, educating people largely on Docker layer caching. We have some ideas for Depot of how we could make that better. So we could, I don't want to say skip over that education step, because I think that education step is always important when it comes to Docker. But there's some things that we can do on the Depot side to make the penalty of not knowing the complexity of Docker layer caching less painful. So to answer the question, it's usually all three.
Yeah, in fact, I've always felt like, if we're looking at the screenshot on your website, I've always wished that BuildKit, it does have this nice capitalized cached. I don't know if I can zoom in there, but the cache line is what we're kind of talking about, right? That one of the benefits of a properly built Docker file is the automatic caching that Docker makes. Of course, by default, that's per machine. That's one of the things Depot does, is it shares this cache throughout multiple machines. But it doesn't really highlight non-cached, right? I always wish like it made them red or yellow so that it would call out, oh, I'm having to do these steps manually. And, sometimes they can, that's the reason you see sometimes these cache lines will say 0 seconds because it didn't have to do anything. It just had to match SHA hashes, right? But then it gets to ones where it has to build it, and then that's taking seconds. Like this one right here. I can't highlight it. Look at that. I think that's magic.
That's all Jacob.
Yeah, but yeah, that build line actually had to run. It had to run the PNPM build, which is why it took 7 seconds. So that's one of the things I feel like you're saying. Like it's a little bit making sure your backend is designed correctly and you have those shared build caches, but it's another of education inside the Docker file and putting things in the right order. I myself, a common mistake that I make is that over the course of a project, especially a complicated one, I will find that there's hidden files that I'm not properly Docker ignoring. So for those of you out there, making sure that everything that's in your git ignore should be in your Docker ignore file. And if you have little hidden files or dot files that get changed all the time, I had this happen with like a security scanner or maybe a linter or something like that would add these little cache files in the directory. And so technically it was changing files every single time. And so my builds weren't ever getting cached, even though I wouldn't change anything. And it was very confusing because it's not explaining, oh, this is the file that changed this time. This is why I'm going to, it doesn't do like explain the build and why it didn't cache it. And I wish it had that kind of debugging mode. But anyway.
Yeah, this is actually a really great point of something that other folks can watch out for, because you can kind of detect that problem if you look at just this output. If you see the line that's transferring context, 2.71 megabytes, you can usually find problems in your Docker ignore if you look at that transferring context line and it's significantly larger than you anticipate. So this is that's just like a Docker file, Docker build optimization that we've learned over the years, helping out teams optimize their Docker files, is they'll ask like, well, why is the build so slow? And then you look at the transferring context bit and it's 2 gigs. And it's like, well, you're probably transferring something up to the builder that you don't want to be transferring.
Yeah, we have a question from Com. Do you propose a rewritten Docker file like Slim AI does?
Yeah, so today we're not, we're not modifying Docker files at all. We'd like to get to a point where we can do things like intelligent suggestions. Today we're taking your Docker file as it is. So if you spend the time to optimize it, like Depot will be the best place to run it because it provides that persistent disk. Yeah. But we're today not altering the Docker file in any way. We do support some interesting things. Speaking of Docker file stuff, Docker and BuildKit, which is the engine that Docker uses for doing these builds, supports some things called cache mounts, which are kind of a more advanced caching feature, which effectively lets you mount a directory in a run statement, and then that directory is remounted when you run it again. So a really good example of this would be like you could have an npm install step, and you could have a cache mount specified for the directory that npm downloads like global packages to. What that means is like when you rerun the build, even if you've changed your dependencies and it needs to reinstall them, it can still like reuse some of that like network download cache. You can do that with like most language dependencies. You can do that with apt installs. You can do that with like incremental builds for languages that support those. So that can be like a big speed up. But you need a persistent disk. Like BuildKit does not offload that cache anywhere else. So you need to be running your own dedicated build machine or using something like Depot provides you that disk.
Yeah, you have to solve the problem yourself, which is kind of what I've been doing today with GitHub Actions. And Docker provides GitHub Actions, but there's a lot of manual stuff, which is essentially why I actually built a bunch of tutorials and eventually a course around it, because it's complicated enough that if you want to light up all these features like remote caching and multi-platform and all the right stuff, you have to first know what you're doing with their tools, and then you have to actually explicitly put it all in there, which maybe leads us into a demo, because I'd love to see exactly how easy this could be versus the way I do it today.
Cool. Yeah, I have something pulled up on my end.
Okay, and by the way, while we're still doing this demo, feel free to ask more questions. We'll get to them during or after the demo, depending on the question itself. And yeah, this is good stuff. All right.
Cool. Yeah, so kind of one demo that we can show here. So on our homepage, we have some benchmarks, some benchmark graphs. What we're doing with these benchmark graphs is we are running a Docker build and a Depot build in GitHub Actions for every commit to certain open source repos. So for instance, PostHog or Temporal, Chamber, Mastodon, we're rerunning those GitHub Action workflows and just tracking how long they take. This lets us kind of keep an eye on how much faster Depot is with more real-world projects. These ones on the top here are running multi-platform builds, which is why they are very much faster. I'm going to take a look at this Temporal one here. So this is running a Docker build and a Depot build for both Intel and ARM on every commit to Temporal's like upstream Docker repo. So in our example here, we're averaging about 15 times faster. We're saving about 11 hours over the last 10 commits of build time. And you can see the times here are like in the 5-minute range for Depot. One thing we've noticed with some of our benchmarks, we're actually a little bit faster than the upstream repo because we are running like the optimized Docker build. I'll go look at the workflow in a minute. But like in the official like GitHub Actions runs, these usually run about like 5 hours. That is all due to emulation. So this is a larger project, and emulation is really, really slow. So this is our repo. This is public if you'd like to go look at it. But this is the repo that automatically pulls in changes and reruns those GitHub Actions runs. So let me look at the workflow. Yeah, so we have a build with Docker. This is kind of copied from Temporal's repo, but we're building several images here. We're using Docker's GitHub Action for these, and you can see we're building for both the multi-platform, both Intel and ARM here. For Depot, we're doing virtually the same thing. Excuse me. If you're using GitHub Actions, we have GitHub Actions that mirror Docker's. So similar to how Depot build implements the same CLI flags as Docker build, we have like a Depot build push action, GitHub action that has the same inputs. So again, it can be really easy to swap out Depot for Docker here.
Can you zoom in a little bit?
Yeah, I can zoom in.
There we go.
Nice.
Yeah, so if you're using Dockers, you normally would have to have that step anyway. You're just swapping it out.
Yeah. So you can swap out the action here. The additional action that we have is this Depot setup action, which is what's downloading the CLI. We've also set up an access token and a project ID. Those are kind of the two things that Depot needs to know to authenticate with your builder. Is which project do you want to build and what's your access token. Yeah, so I can also run this locally. I have sort of translated these into a CLI command here. Yeah, so I am in the repo. we're saying Depot build instead of Docker build. And then these are the command line flags that Docker would take. It's a little bit more complicated than normal because we're like explicitly telling it to build a Git repo instead of local files. But if I run this is going to launch. We're see 2 builders for ARM and Intel, and then connect to those, and then do the build. And in this case, the entire thing is cache because it is already built over in this GitHub Actions run. So this is kind of that cache sharing thing. So yeah, we can see that run. I could force it to run the build with no cache. And that's going to be similar. This is going to run everything from scratch, but you can kind of see, this is the build kit output. You can see the Intel ARM 64 lines and the Intel AMD 64 lines. It kind of communicates with both Depot builder instances at once and coordinates the work between them. Yeah. Yeah. Any questions or?
Well, it's a much shorter YAML statement in there than you would normally need with Dockers. And because I was imagining like, okay, I got to set up where I got to talk to Depot, and I love that it's one action step to sort of initialize it, and then it's just replacing the build push. So it's I'm going to guess on mine it would be a 10-line YAML replacement to basically outsource my builds. The other nice thing here is that I believe that GitHub Actions is charged by minute, right? So this will reduce the amount of GitHub Action minutes I need.
This greatly reduces the GitHub Actions minutes you need. And GitHub Actions gives you like the bundle of free minutes. So this can mean you like don't have to pay anything, which is kind of nice. On other CI providers, like say Circle CI, that have a charge for all minutes and not a free tier in that way, this can potentially like reduce your bill by quite a lot. It's not only do you have like less time, but all the build is happening remotely, so you don't need like large instances. You don't need a lot of like power in your CPU or in your CI runners. They're just kind of starting the command.
Yeah, because that those larger servers can get expensive pretty quickly. I'm sitting here in my head trying to think: is there a way to do the analysis to say you saved, like the AWS bill analysis companies?
Mm-hmm.
I'm imagining like this page on your website, or you show me how many minutes I saved on builds, how many dollars in GitHub Actions or in other CI platforms that I saved this month.
It's definitely something. That's definitely something that we're working on. We want to like surface how much time you've saved, because it's exactly that, right? Sometimes within engineering teams, we all have higher ups that we have to report information back out to, and so being able to like capture that snapshot in time of what Depot is 15 times faster, so we saved this number of minutes, which equated to this number of dollars in the CI provider.
Yeah, and the fact that this is as long as you have internet. No, let me. Is there a self-hosted version of this, or will there be?
Yeah, so we have 2 modes of hosting. One is the mode you're seeing right now, which is Depot hosts the machines, the build machines. So you kind of don't have to think about infrastructure at all. We have another mode if you have like a requirement that your build data and build context remains within your own cloud account. Depot can spawn the build machines in your own AWS account. Like we have a way of connecting your AWS account to Depot. Depot, the UI on the website still stays hosted with us, but the Depot CLI will communicate directly with your builders in your own account, like without passing through Depot infrastructure at all.
Right.
So we have several customers who like that if they have a more strict compliance requirement to keep things under their own control.
Okay. Yeah, that was similar to Conrad's question about local builders with Depot. Ryan's asking a similar question. So what happens at the end if I'm building locally? Does this thing actually pull the image down to my local image cache after it's done?
Yeah, so you have three options there. One, you can just build it and do nothing with it. It'll remain like in the builder cache. So that's good for like testing that a build worked, or like prepping the cache for CI or something like that. Two, you can pass a load flag, and that downloads the image from the remote machine to whatever machine you're on, whether that's CI or your local machine. It like loads it into Docker so that you can directly Docker run it. The third one is there's a push flag, and that will push it to a registry from the remote machine directly over like a fast network. So you kind of have the option to pick what you'd like to do based on what you're doing.
Nice. Yeah, that sounds similar to the build kit or the build X options we have today in Docker, which most people don't know about because there's that hidden complexity hidden behind the build X command. And, a lot of people still just do Docker build today, so they don't really know about all this advanced stuff and the build X stuff. So it's kind of great that you're surfacing that inside your tool. So where do we go from here? So I've added this to my CI. I'm doing this. So what else does the UI do for me? I mean, it feels like a lot of this I'm just doing outside of your UI. I'm doing it either in my GitHub Actions or wherever I'm storing my CI configurations, or maybe I'm just running it locally on my machine.
Yeah, today it's largely that. Today there's not a lot inside of Depot, the UI. What we're working towards is different things that we want to surface if we're a part of this process. So this is things like telemetry of your Docker builds, build traces, like where's the hotspot in your build. I believe earlier we talked about Docker file suggestions. Those are all things that we can analyze and surface back to you. And so that's the next set of things that we want to add to Depot as like the application. First, we wanted to nail the developer experience and meet folks where they are and make it really simple to adopt. And even if you choose not to adopt it, make it really simple to compare side by side. Is this going to improve your build performance by orders of magnitude? And so now it's thinking about all of the features that we can surface into Depot now that we know more information as the build is happening on the remote builder.
Yeah, I can imagine some heuristics around over your last 10 builds. This one particular step is the one that's taken up 99% of the time, and like stuff like that we maybe. I mean, I'm pretty passionate about this stuff, right? Like when I work with teams, I'm the Docker guy or whatever. And so I find that a lot of developers aren't as passionate about build tools and the build pipelines and stuff like that, which is fine. Like we all got our own responsibilities, which means ultimately that once the Docker file works, it doesn't tend to get a lot of attention after that until it breaks or until they need a new thing in there, or unless security comes calling because too many CVEs, or there's a new requirement outside the team that requires the team to adjust. And I do tend to talk a lot especially to the Docker team about the fact that these tools continue to evolve. You guys are new in the space, but like Docker's not sitting still, build kit's not sitting still. There's lots of other build kit or Docker build alternatives for local building or whatever that have shown up, and they all have a little niche, a little problem they try to solve here and there. And most teams don't have, unless you're a very, very large company and you have a dedicated build team or whatever, these things don't get a lot of attention, I guess is what I'm saying. And so I always appreciate it when tools like this show up and try to resurface a lot of this analysis on the back end that maybe you could do on your own, but a dev is too busy. The typical dev has got too much on their plate from the feature list that the never-ending feature list they have to develop. So they always want the thing to just be faster, go faster. And it sounds like maybe someday either you're teaching them stuff that they didn't know, allowing them to build their better Docker files, like even just, hey, multi-stage this thing, right? Make it a little better. Or giving them analysis on where their builds are slow, which may actually cause them to realize, well, let's do a dependency review. Oh, we don't need this anymore, which it's amazing how many teams I talk to with old monoliths that don't really know how those dependencies or why those dependencies are there, especially when it comes to like, Python or Ruby apps that have apt dependencies, and there's some old MongoDB driver still installed in the container, but they've maybe switched to Postgres, but the Docker file still puts in a MongoDB driver in the apt or whatever, or I'm thinking maybe a PHP in the Perl stuff back in the day. But anyway, there's a lot that I think if we all went to our own Docker files and audited them, I imagine we would all make at least one change. And I think that there's always value in adding more and more of this stuff into the build process. And it's amazing how long it's taken for these companies to get there. So I'm excited for the future and excited for what you all have here. I'm kind of wrapping up the demo. I didn't mean to. Was there something else you wanted to show?
No, I think that's it. Yeah.
All right.
Yeah, I think we covered it all.
Yeah, well, and it's early days. By the way, congratulations on being a part of the Y Combinator Accelerator. For those of you out there that want to take a look at Depot, can they just go to your website, click the getting started or sign up or whatever and get going?
Yep. You can go to Depot.dev, and we have a 14-day free trial, and we're also always happy to jump on calls and communicate over email and help folks switch over, set up a parallel CI test in their environment to see how things look side by side. It's all self-serve today. So give it a whirl and let us know what you think.
Yeah, that's actually a great idea to get started, is that you don't have to necessarily change your existing production pipelines. You could just copy it over, we'll swap out the Docker for the Depot and then see what happens. Yeah, that's an interesting experiment for sure. Well, I'm looking forward to giving this a shot myself. I've got certainly a lot of projects out there for my courses and open source that build images slowly because I'm constantly building a multi-platform. And that's one of my big things for me is the multi-platform advantages. Anything else from the people out there? If you've got any questions, this is it. We're wrapping it up. They can find you both on Twitter. I put your Twitter profiles down there. You can also find I don't actually put the link to Depot in chat, but I'll throw that down in there for people. Depot.dev. And we'll give people the last couple of seconds. What do you give us? Is there anything near term that you're looking to add? Like any features on the horizon you want to sneak peek?
Lots of them. I think there's a lot of interesting stuff that we can do with build analytics and build tracing. So that's kind of the next feature set that we're looking at. We're also exploring some of the GPU type of. There's a lot of folks that are doing CUDA types of stuff inside of Docker images, and so we're looking at a few different things in that realm. So that should be exciting as well.
Interesting. I'm curious. I'm just still excited about the ARM native support. So that was, I think, the thing that got me most interested when I first heard about you all. So I've wanted to do that myself on GitHub Actions, but there's such a process to do all that. Manage my own runners. I'm a team of one, so I don't want to manage any runners.
Yeah.
I don't want to do any of that stuff. Yeah. So, all right. Well, the queue is empty on the questions, and I think we've answered everybody's curiosity. So thank you so much, both of you, for being here, especially as we're all recovering from some sort of holiday flu or cold. So for those of you watching, if you didn't know, this comes out on a podcast about a month or so after the fact. Below, you'll see the link to the podcast. You can get the podcast pretty much anywhere. Just search for my name or Docker and DevOps, and you'll probably find it. And we will be, I'll be here live next week. Sorry. You can become a YouTube member. I did not mention that. Thank you to the YouTube member for today. What was his name? Evilist Steve. So the Evilist Steve is now a member of this YouTube channel. Thank you so much. I appreciate that. And we've got coming up in the future, let's see, future guests. We've got Project Calico for Kubernetes networking. and we're going to start adding more Q&As. So meaning that there'll be just shows, maybe guests, maybe not, but we won't have any agenda. We're going to be here just to answer your questions, hopefully correctly, about things like Docker builds and Kubernetes and all the other container stuff in cloud native. So stay tuned for that. Again, live here every Thursday. Thank you, Kyle. Thank you, Jacob. We'll see you soon. Ciao, everybody.
Thank you.
Thank you.